Okay, welcome. Today we see about the topic of fins. Okay, so the name is called extended surface. Okay, so we study about the extended surface before we know about the Newton's law of cooling. Okay, so this is a Newton's law of cooling. So what is meant by Newton's law of cooling? That is a heat dissipation occurs in rapidly. For example, taken as a cup of coffee. Okay, taking a cup of coffee, it becomes nearly 70 degrees Celsius in placed in atmospheric temperature. Okay, so that is nearly 35 degrees Celsius. Okay, it takes nearly 15 to 10, 15 minutes. Example, I tell you 15 minutes to take 70 to 35 degree temperature. That is high temperature to low temperature. Okay, so in compare with we taken a large container like a cup of coffee. Okay, so it have put same amount of uh, coffee is put into the large container that have initial temperature also at 70 degrees Celsius and its atmospheric temperature is 35 degrees Celsius. Okay, but it take a cooling time it has when compared to cup of coffee. There is nearly 10 minutes or 5 minutes. Okay, so why it is time is reduced? Because the surface area of the pan is increased, the heat dissipation is also increased. That means heat transfer should be increased. Okay, so same concept, the Newton's law of cooling said to increase in the surface area, the heat transfer should be also increased. That is why heat dissipation should be increased. Okay, that's why the reason extended surface working on the principle of Newton's law of cooling. Okay, is a formula for Newton's law of cooling. That is Q is equal to H into A into Ts minus T alpha. Okay. So, for example, you're taken as a pipe. Okay. The flow of fluid into the pipe, that is a fluid having the temperature is at 300 degrees Celsius. Okay. And surface, that is at surrounding temperatures, that is 35 degrees Celsius. Okay. The fluid become outlet, we're having the 290 or 250 degrees Celsius. Okay, so the having same surface. Okay, so 300 degree fluid should be exit out 250 degrees Celsius because of 35 degrees Celsius of atmospheric temperature. So to increase the heat transfer rate, how it can be increased by increasing the it's possible to increase in a convective heat transfer coefficient. So what is meant by convective? Already I told what is convection. The convection is the transfer of heat by means of heat transfer between a solid surface to fluid medium. Okay, that has happened. There is a solid surface. The fluid medium as a air. That is, the fluid is also now having the solid, liquid or gas. Okay, so the air medium is a gas medium. So the transfer of heat between solid and the fluid medium, that is a convection. Okay, so why we call it as a convective transfer coefficient. But this does not should be increased. Okay, it is a constant value. But if the temperature of surface also should be increased, but it is a surrounding temperature, that is atmospheric temperature. Okay, we should not be controlled. And flowing of fluid in the pipe, it is a 300 degrees Celsius, it should not be changed by ourselves. So only we change surface area. Okay, so to use increase the surface area, the heat transfer should be increased like a fin model. Okay, so this is the surface area. To increase the surface area, the heat transfer or heat dissipation is rapidly increased. So you having a 250 degrees Celsius outlet, we using the fins, we have 200 degrees Celsius. It consumes the less time. Okay, so this is the extended surface. Okay, so the extended surface, otherwise called a fins, the fin is possible to increase the heat transfer rate by increasing the surface of the heat transfer. Okay, so the surface is used to increase the heat transfer rate, that is called extended surface. Okay, so there is a lot of types in the extended surface. uh, that is a straight fin, that is a uniform straight fin. This type of fin called as a uniform straight fins, and this is a tapered fin, and another one is a spline. Okay, So this is called a tapered spin, fin. Okay, so this is a state fin, and it is annular fin. This is a cone fin. Okay, there is a lot of type of fins, various used for in various applications. Okay. Next, so what is the main application of fins that is placed and used in electronic components? Okay, so we already see in computers or laptops, the exist of fans should be used to remove the heat from the electronic system. So that system having manufactured by that's like this fin. The heat is sent out the environment from electronic component with help of fins, and we use in more engines. Okay, so we use in two-wheeler engines. We use of two-wheeler engines, for example, once again, of two-wheeler engines, and then use a radiator and transformer. Okay, so let's see, this is the fin used in the engines. That is a air-cooled engines. So mostly it is present in two-wheelers. Okay, that is a user. If you want four-wheelers, we use a radiator. This also made up of radiator inside having the fins. So this is a refrigerator. Okay, so that's why we can use the fin in the system to remove the heat from, or dissipate the heat that becomes rapidly. Okay, so why can use in the fins in the electronic components? So this is a electric transformer. That is like this is a fins are present in the electric transformer. So this is a radiator. Okay, then already we see about the types of fins. Okay, so this is a very important, and most of time is asking questions. It's a spline spin, spline. Okay, so that is a stepper, and it is a state or uniform state spin. Okay, so what are the heat transfer placed in the fin? We have some diagrams out there. Okay, so this is a fin diagram. Okay, so this is called a fin base. The base element are there. Heat is transferred to the first in the fin base. After the fin base, we conduct the heat. So why we call the conduction on this area? Because we already know what is a conduction. The conduction is a transfer of heat from pure conduction from solid to another solid medium. So that is a conduction. So heat is transferred to the first in the fin base. There is a solid conduction. There is a solid to solid. That is a conduction. So having the convection and radiation, that means it's possible to three modes of heat transfer is combined or related with transfer of heat from solid to fluid medium. So I already told what is solid to fluid medium of heat transfer is convection. Okay, so taken a heat transfer in the convection, there is a no medium, there is a no transmitting medium, that is a radiation. Okay, so the both convection and radiation are present there in heat transfer fins. Okay, so some of the formulas are used to find out the efficiency of the fin and the effectiveness of fin. Okay, so next we see about the efficiency and effectiveness of the fin. Okay, so what is efficiency? We already know the efficiency of the fin. It represents the actual efficiency. Okay, so actual efficiency, that is a heat is transferred from the fin. That is a actual efficiency of the fin, and how much amount of efficiency to be that heat transfer to be from the fin. That is the maximum efficiency. The maximum level of heat is dissipated from the fin. That is a maximum maximum heat transfer. That is a heat exchanger. That is a Q fin max. Okay, Q fin divided by Q fin max, the actual value of heat transfer, that is a rate of heat exchanger, that is a actual heat transfer to the maximum possible of heat transfer from the fin, that is a Q fin max. Okay, so the formula for already given, we know that Q value, that is a, we use a Newton's law of cooling. So Q is equal to HA into Ts minus T alpha. That is a Ts is a surface temperature, T alpha is a atmospheric temperature, that is a surrounding temperature. That is a, we already know the Q fin. So Q fin max means the possibility of Q fin is maximum to dissipate the heat. That is a Q. That is a Q fin max. Okay. So next we see about the fin effectiveness. Okay. So fin effectiveness, that means uh, we exchange the heat or transfer of heat to the uh, without use of fin. Okay, so that means the performance of fin, the judges based on the enhancement of heat transfer related to the no fin. Okay, without fin or with the fin. Okay, the ratio of the heat transfer rate from the surface with the use of fin to the without use of fin. That is the effectiveness. Okay, we already know the Q, rate of heat exchanger. That is the value from, there is a formula from Newton's law of cooling, Q. Okay, so that is a convection. Newton law of cooling means there is a convective heat transfer. Okay. Okay. So next we see topic of lumped system analysis. Okay. So before you find out the heat transfer rate from unsteady state condition, that means that you find out the this is a metal, there is a rectangular element. Heat transfer rate becomes the thickness, that is a distance, that is a dx. We know that the distance and with respect to time. Okay, so that means f of x comma t, we find out the heat transfer rate. But lumped system analysis is based only on T, because in this lumped system, the internal conduction of heat resistance becomes very small. So, very small element should be taken account of the heat transfer. So எவ்வளோ சின்ன எலமெண்ட்டை வந்து heat transfer occur பண்ணா அதோட temperature மட்டும் there is no changes. For example, unsteady state condition பார்த்தீங்கன்னா we have the temperature. For example, one second. Okay, so this is unsteady state condition. Okay, so that is a transfer of heat T1 and exit of so something. So in this area, the temperature should be reduced. Okay, so that is a T2. So T1 is a 300 degrees Celsius input temperature. In this area, 270 degrees Celsius, and T3 becomes the 250 degrees Celsius. And we go to this point becomes a 280 degrees. So temperature should be changed in every position. Okay, but in lumped system analysis, already we told that is a lumped system means we have a small element. A small element, for example, taken as a ball bearing, bearing balls. If there is a small element, it should be treated as a heated in nearly 200 degrees Celsius. Okay, so we put on the atmosphere, becomes 70 degrees Celsius. Okay. Okay, so that is atmosphere temperature 35 degrees Celsius. We put on in 1 hour. Okay, so 70 degrees Celsius, the temperature measured from this area 70 degree, and this area becomes also a 70 degree. So we have the position should be changed, but the temperature should not be changed in the lumped system. Okay, so lumped system means the heat conduction in the small element is the lumped system. It is a representing conduction resistance. Okay, so let us consider a small heart. Already told a small copper ball. It is taken as a furnace. It is placed in the new environment. That becomes a constant temperature. The environment temperature becomes a constant temperature with particular time. Okay, so the temperature should be changed from 200 to 70 degrees Celsius, but the position of the element should not be changed. The same 70 degree in Celsius in the given element. Okay, so after half an hour it becomes 50 degrees Celsius. Okay, reduction in temperature because our atmosphere temperature is 35 degrees Celsius. Okay, so the 50 degrees Celsius we measure the 50 degrees Celsius each in every position, that the temperature should not be changed. The same 50 degrees Celsius in all the points. Okay, that is a lumped system with respect to time. Okay. Okay. Next, you see about the Hazelitt chart. Okay, this is used for in problem. So problem use பண்றது நம்ம Hazelitt chart use பண்ணுவோம் to find out the solution of problem. So it is a graphical representation of heat transfer. Okay. So before you find out the theoretical and practical level of heat transfer, but you do go for use of here already number psychomet chart use பண்றோம். Hazelitt charts like this is okay. This is Hazelitt chart. So next class la பார்க்கலாம். Okay, next class we see about Hazelitt chart. So use of Hazelitt chart in the problems.